So let's check out this problem right here. Given the integral from 5 to 10 of f of 3x dx equals 16, find, whoa, wait a minute, overwhelmed. Do we know what f is? No, but you don't have to know. So sometimes they'll give you stuff and just want you to use your knowledge to work your way towards this. And maybe it'll work out in the process, and hopefully it will. Hint, it will. So let's cover this up, ignore it, and work with this. So doing the same thing we've been doing, I can identify the inner function, which of course is u. The derivative of u would be, well, 3 dx. And if I am really dealing with this, just this, now, well, I'm aiming for this. Don't worry about this. Don't worry about what you're aiming for. Let's just keep running with what we have. We'll eventually get here. Really, sometimes we can get overwhelmed with all this, and then I got to work towards this, and yeah, just hold that thought. Okay, I'm going to just keep working with this. All right. So since I have that, I'm going to bring it down here, and we're going to say we really have the integral of f of 3x dx from 5 to 10, and that is equal to, well, the integral of f evaluated at some function u, and then du. But here's the problem. So like if I'm going to go like old school color coding this like we had done in previous lessons, or previous lesson, we have the 3x here, which is u. We have dx, which is du. Oh wait, dx is not du. So we got to go one more step over here, and we're going to say that dx is really 1/3 du. Okay, good to know. So we really have a 1/3 in front of all this thing, or in front here of the f, that's okay. But what we can't do is put the 5 and the 10, because we've changed this inner part, so we're going to have to change this. So 5 goes into the x here, and we have 3 times 5, which of course is conveniently 15. Oh, see what's happening now? See it? Hope so. And then we plug the 10 in, we get 30. Oh, there he is. There's that convenience again. And this is what we have. Okay, so let's just stop for a second, kind of stare at this and figure it out. If the integral from 5 to 10 of f of 3x dx is equal to 1/3 integral from 15 to 30 of f of u du. So u is a function, and you could be like, oh, let's plug the u back in. No, don't actually. So at this point, things are shaping up so much that you could say this is pretty much this. So let's just keep going. We're just going to reassign some variables here, right? So like 1/3 integral from 15 to 30. You can just change a u to a t. Well, for our purposes, yes. Like I'm aiming for this. Don't panic that it changed from a u to a t. It's really the same idea, because at this point, u is not going to necessarily represent an inner function so much as it is just a number at which we evaluate something, right? So we don't have to plug in 3x right here. That's just a little counterproductive. And we'll just use the variables they gave us, because now it's obvious, and we're going to try to make these look alike. Well, here's the deal. This is 16. We haven't even talked about that 16 yet. There we go. So we get that. That's lovely, isn't it? I think so too. I like it very much. So what I really want is this, which equals 16, and also equals this, to eventually help me get this thing by itself. So the integral from 15 to 30 f of t dt is equal to 16 times 3, which would be 48. And that, my friends, is how it's done.